Today's lesson is 1-2, Understand Rational Numbers. Let's start in your workbook on page 15. I'll give you a second to find that, so go ahead and pause me. When you're ready with page 15, turn me back on. All right, it says solve and discuss it. Calvin wants to customize his surfboard so that it is wider than the 82 model, but narrower than the 92 model. What measurement could be the width of his surfboard? All right, so let's go ahead and start with some important information. We know that Calvin is going to make his own surfboard, and he wants it to be wider. Let me undo that and get a highlighter. He wants it to be wider than the 82 model. Well, if I look at my data, the 82 model is 22.5 inches wide. Some more important information. He wants it to be narrower than the 92 model. Well, the 92 model is 23.25 inches wide. So I think what we want is something in between those two. So I'm going to give you some time to work. First, you're going to think solo, then you're going to talk with a partner, and then you're going to come back and check with me. Go ahead and see if you can find an answer. We've been talking a lot about representations, so I drew you part of a ruler, and it looks like model 82 is going to be 22.5, so that's right here, inches wide, and the 92 model is 23.25, so that's right here. And he wants it somewhere in between there. Well, there's an awful lot of numbers in between there. If I wanted to change these to a decimal, because sometimes decimals are a little easier, 22.5 is the same as 22.50. And 23.25 is the same as 23.25. So if we thought about this as money, we're looking for anything in between there. So if you have something between there, then you have the right answer. If you kept it in fraction form, you could have said anything like 22.75, 23, 23.18, any of those kinds of numbers. All right, we are ready for page 16, and this is example number 1. It says Juanita is reporting on pitching statistics. Pedro's fastball statistic is 52/80ths. How can Juanita write the fastball statistics in decimal form? So we have this fraction, but we don't want it to be a fraction. We want it to be a decimal. So I'm going to give you a reminder. This fraction bar means that we are going to divide. Another representation that you're going to see a lot in the workbook this year is called a bar diagram. And so right here, they have a bar diagram made for you that shows Pedro's statistics, 52 fastballs out of a total of 80 pitches. We also have it in fraction form. Now your book goes back to long division. We're not going to do long division this year. I'm going to let you use a calculator for it instead. So let's talk about how you're going to go from this fraction to its equivalent decimal. You are going to start with the top and work your way down. You're going to start with 52. You're going to hit your division key. You're going to hit 80, and then you're going to hit equals. And your final answer will be 0 and 65 hundredths. Now there is some vocabulary for you here. 0 and 6500ths is called a terminating decimal because it's going to end or it's going to stop. They say it's going to end in 0, which technically it does. I could go ahead and put a 0 on the end of this. It doesn't change its value, but sometimes it's easier for kids to think about terminating is that it stops. Here is your try it on the bottom of page 16. It says in the next several games, the pitcher threw a total of 384 pitches and used a fastball 240 times. What decimal should Juanita use to update her report? So I'm going to point out to you that we have our bar diagram, 240 out of a total of 384. If I wanted to write that as a fraction, it would be 240 out of 384. Now your book would like you to use long division. I'm not overly interested in spending your time on long division. Let's go ahead and use a calculator. So I'm going to remind you that this means to divide. Go ahead and pause me, do your division, fill in your box, and come back for checking. All right, your calculator should have given you, after you did 240 divided by 384, should have given you the terminating decimal of 0 and 625 thousandths. So that's what you should have written in your box, but my box isn't big enough for my big old handwriting, so I'm going to put it right here. It is a terminating decimal because there is an end to it. There's a last number. All right, you are going to stop the video here. I want you to complete the following workbook questions on pages 19 and 20. Please complete 13, 15, 16, 17, 19, and 21. Now there is an answer key available for you. As you complete each problem, I want you to get up, walk over to the answer key, and self-check. If you have it right, give yourself a star, and if you don't have it right, I want you to fix it. All right, it is work time for you right now, so go ahead and stop the video. We are going to move on to example number 2. This is on page 17. It says a class votes on whether to change their school mascot. How can you express the number of students in favor of a new mascot in decimal form? So we have some data in our picture right here. It says in a class of 18 students, 5 voted to change their mascot. So if I wanted to write that as a fraction, 5 out of 18. Again, your book would like you to use long division. I'm not interested in spending our time on long division right now. So instead we're going to use a calculator, and you're going to take 5 divided by 18. Now your book did that for you, and it said that it came out to be this until the end of the calculator. That's called a repeating decimal. There is no end number. It goes forever and ever and ever. Now there's a couple of ways you can write this. Sometimes in my Google Forms, I have problems with bar notation, so I might write it like this, 777 ... tells you it's going to go forever. But in math class, generally we like to use bar notation. That means whichever digit or digits are repeating, in this case the 7, there's going to be a bar over the top of it, and that tells you that that 7 goes on and on and on forever as a repeating decimal. This is the try it under example number 2. So I would like you to use your calculator, and I want you to give me the decimal form for each of these 3 options and tell me whether it's a repeating decimal or a terminating decimal. So pause the video, work those out, and when you're ready for checking, I want you to come back. All right, the first one I took 100 divided by 3, and I ended up with 33.333333 all the way to the end of the calculator. There was no end, so I used my bar notation to show that the 3 is going to repeat after the decimal forever and ever and ever. And so this is a repeating decimal. Whoops, let's spell that correctly, Mrs. Weeks. Sometimes it's hard to talk and write at the same time. All right, our second one, I took 100 divided by 5 and I got 20. There's an end to that. That's it, just 20. And so that one terminates. And our last one, I took 100 divided by 6 and it came up to be 16.66666 to the end of your calculator. There might have been a 7 at the end of that just because your calculator will round your number to make it fit your display. But in reality, that would have gone on forever. There's no end to it, so I used my bar notation to show that the 6 after the decimal is going to repeat forever, and that makes this a repeating decimal. All right, I want you to stop here. I want you to please complete the following workbook questions on pages 19 through 20. Please complete 6, 7, 8, 9, 11, 14, and 19. And again, as you complete a problem, I want you to get up, go to the answer key for self-checking. If you have it right, give yourself a star. If you are not right, fix it. So go ahead and pause me and get to work. We are on example number 3 on page 16, and we are going to have a new vocabulary word. Eventually, we're going to get this into our vocabulary sheet on page number 6, but for today, what I need you to know is that rational numbers do two things. Rational numbers either terminate, I'm going to run out of room, let me put this one down here, or they are going to repeat. If they don't stop or they don't repeat, they're not rational. So let's go ahead and check out these examples. Here's A. Notice there's an end number here. It terminates, so it's rational. On B, do you see this bar notation right here? That means that we have a repeater. If it repeats, it's rational. But let's look at this last one. Do you see this dot, dot, dot? There's no bar notation. It's just a bunch of random numbers that are never going to end. If it does not repeat and it does not terminate, it is not a rational number. This is the try it at the bottom of page 17. I want you to decide, is this a rational number? Is this a rational number? So you're going to say yes or no and then give me a reason why. Go ahead and stop the video here, work on this, and when you're ready for checking, you're going to come back. All right, our first example has this lovely bar notation. That means it's a repeating decimal. If it's repeating, it is rational. Whoops, let me change my color back to blue. It's a repeater, so it is rational. Now my green example is a little trickier. I see my dot, 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 but I don't have an exact pattern. I have 1, 4, then 1, 4, 4, then 1, 4, 4, 4. These are not exact duplicates. That means it's going forever, but it's not repeating. It is called irrational. That simply means that it is not rational because it does not stop and it does not repeat. Okay, you're ready to stop again. I want you to please complete the following question on page 20. It is question number 18. As you finish it, I want you to go and check against my answer key. If you are correct, I want you to give yourself a star. And if you are not correct, I want you to fix it. Go ahead and pause the video, work on it, and come back when you're ready to move on. All right, let's get ready to do some math reps. I want you to find your math reps page that I gave you yesterday. So pause me, go find that, and then come back. When you're ready, you're going to start the video again. All right, here are some hints, tips, and advice. So question number 1, when I ask you for the additive inverse of a number, what am I asking you for? You have 2 places that you can look for this. You have page 6, which is your vocabulary page, or there is a word wall on the back, in the back of my classroom. You're looking for the card that talks about additive inverse. All right, question number 2. If I have negative 42 and I add this number and it brings me up to 0, what would that number be? And then question number 3, write an integer for this situation. Again, there's a card on the word wall on the back, in the back of the room that's going to help you remember that an integer has 2 parts. It has a sign and it has a number. So I want you to pause me, answer those 3 questions, and then come back when you're ready for checking. All right, here are your answers. An additive inverse would be the opposite number. Number 2, when you add 2 inverses, you will get 0. So the opposite of negative 42 is positive 42. And the integer for 62 degrees outside would be positive 62. But remember, you have the option of whether you want to put that plus sign or not. If you just want to write it as this, that is totally acceptable. All right, day 3 math reps. You're going to take negative 7 and 5/10. You're going to add this number to it. It's going to bring you to 0. What is the number? Number 2, you're writing an integer. Remember that word wall card says you need 2 things. You need a sign and a number. Number 3, what is the additive inverse of 9,652? Number 4, what makes a decimal terminating? And number 5, what is the decimal equivalent of 3/4, and is it repeating or terminating? All right, you're going to pause me and work. When you're ready for answers, come back. Here are your answers. Number 1, if you add 2 inverses, you will always get 0. So the opposite of negative 7.5 is positive 7.5. Number 2, an integer has 2 parts. It has a sign and a number. When you are winning something, that is positive, so it's positive 2. But remember, you always have the option. Do you want to use that positive sign or not? So if you don't, just a regular 2 is fine. Number 3, an additive inverse is the opposite. Remember, we're going to use parentheses around our negative number to show it is a negative sign and not a subtraction sign. Number 4, a terminating decimal either ends or stops. And number 5, to change to a decimal, we would divide. 3 divided by 4 is 0 and 75/100ths. Because that decimal stops, it is terminating. All right, good job today. Well played.